So let me add the node, and the second one would be transformation. So what do you want to do, or which transformation you want to use? There is this data preparation. We can change the schema, we can join, we can run an SQL query, do some aggregation, do some custom transformation, drop duplicates, drop fields, filter, rename, etc. So all these are nothing but Spark transformations that you can think of, or the Glue APIs. Glue also provides certain transformation API, which are a wrapper on top of Spark data frame APIs only, or Spark RDD APIs only. So in this case, I will select the join transform, and by default it has been added here. It can be added anywhere, by the way. But what you have to do, you'll have to join all the 5 tables. Okay, so here now I'll be selecting this join transformation, and then I can select node parents. Here the node parent is only S3 transaction, but I can add other node parents or parents also, like account, customer, ledger, and loan. The moment I select all of them, it says that the parents of this node have overlapping field names. AWS Glue Studio can add apply mapping node to rename them and avoid downstream issues. The reason you get this is because there are tables across this wherein the names are same. The column names are same, and that's what Glue is saying. That is the first error. Then the second error, it says that you need to choose exactly 2 parents to join transformation. Obviously, that should be the case. I cannot select all of them. Now I'm selecting S3 transaction and S3 account. And in this case also, there are certain overlapping names. I'll ask Glue to add the right prefix. So if I click on resolve it, there would be one more transformation which will rename the fields from account. So now I'm joining transaction and account, and this is the node again. So after the node parents are decided, then I'll have to mention the join type also. Here I want to do some inner join, and then I want to make some join condition. Now these are the 2 tables. One is the S3 underscore transaction, and then we have renamed keys for join. I can change the node here. So let me go here and name it as S3 account renamed. And that's it. Come back to the join node again. Now the names have been changed. We have this S3 transaction and S3 account renamed. So account ID would be the ones, that is the first join key. I think that's it. Nothing else is needed. So this transformation is done. So I'll save it and I'll name it as, this node should be named underscore account underscore join. The reason I have named it because there should not be any confusion, right? So this is what you do in PySpark code also. Okay, so the second one is done. Then I'll have to join with the customer also, because there's this customer ID here, and I'll have to make sure that I get the customer information also. By the way, I'm getting all the columns, right? I can do some filtration also. Maybe I'll do that later on. To do the join, I'll have to join with this transaction account and customer, right? So I'll be adding one more node, and the node would be a transform node, and here the option would be join. And I'll name it as transaction account customer joined, because it would make sense. Okay, now I'll have to add one more parent, which would be customer. Now when I say parent, it is nothing but joining these 2. It would be an inner join, and I'll add condition for the transaction account join. I'll add right customer ID, and here it would be customer ID. So that is the condition. So let me save it. So I have joined 3 tables. No coding has been done so far. Here how the DAG looks like. These 2 tables have been joined first, then I joined the customer with transaction customer join. Then I'll need one more join, because I'll have to join with ledger also. I'm not sure whether it is needed or not. Let's look at what records are there in ledger. Click on this and look at this data preview. So let me expand this. I have this ledger ID, transaction ID, account ID, ledger type, amount, etc. There's this transaction ID which can be used as the join condition with the transaction account and customer joined data frame. So let me add one more transform, which would again be join. Of course, you can use other things also. Eventually, I'll be using drop fields, but let me add join because I want to join all the 5 tables. And this is the node, and I'll name it as transaction account customer and ledger joined. And for this, the parent would be only one, which is the join of transaction account customer and the S3 ledger. And here also I'll make the changes. There are certain name conflicts, so I'll resolve it and add the condition. All right, this is done, and let's add the last join node wherein I'll join it loan. I'm not sure whether it is needed or not. Let's do some preview of data. So you have loan ID, customer ID, loan type. So I think we can join with customer ID. There's no business statement here. I'm just showing you how it can be done. Of course, if there are business statements, you can write it as per the business statements. All right, so let me add the node, which would again be a join node, and I'll name it as, it's a pretty large name, transaction account customer ledger loan joined, and the parent would be loan. That's it. And I'll have to resolve it, do an inner join. There should be customer ID here, and there should be customer ID here also. That's why it had to resolve to write customer ID, right? Okay, so this is done. I have added a lot of transformations, meaning that I have done a lot of joins, and this is how the DAG looks like. Now, finally, I do not need all the columns, right? So we'll have to drop columns. So in that case, I'll be adding one more node. And in the transformation, you see there are multiple options, right? We have data preparation, change schema, join, SQL query, detect sensitive data. This is not there in PySpark, but it is available in Glue. So I can add this detect sensitive data. I'll go ahead and add the final node, which would be drop fields. Now let's say you want to delete this. Let's say you have added it accidentally. You can delete this node also by clicking on this icon. So the node has been deleted. So let's see what else can be added. There is an option of select fields. Let's add this select field. I think it got added here, but the parent would be detect sensitive data. Now, if I use detect sensitive data, then it's pretty difficult to get the fields. So I'll drop this node, which is detect sensitive data. I'll do it later on. And here I'll use select fields. Now it will show you all the fields which are there. And if you click on that, it will keep only the fields which are needed. Not only that, I can delete this node, and let's add drop fields. And the parent would be the last node, which is this one, and it has been added here, which is drop fields. Now you see all the fields are shown here: transaction ID, source account ID, destination account ID, amount, currency code, etc. Everything is shown here. Now I can drop the fields that I needed. It is similar to PySpark drop API. So let's do that. So I'll be dropping all these fields. I do not need all these fields in the output. So let me save it, and then I can add one more node wherein I want to detect the sensitive data. Select fields would be opposite to drop fields, wherein I just wanted to select. But before that, let me rename some of the columns, because in some columns you have this write loan ID, write entry date. I want to change it. So I'll be adding this rename field transformation here, and the parent is actually drop field. Now it'll tell you, or it'll ask you which fields you want to rename. So let's select the write balance, and I'll name it as account balance. This is the first field that I want to rename. Then I want to add one more rename. I can search it here also. So rename field, which is one more rename, and here I want to rename, let's say, the one with the right ledger ID, right ledger type. So I'll add all of these one by one and then continue with the video. One more thing I just wanted to show you, that using the rename field, you can rename only a single field. You cannot rename multiple fields. If you have a lot of fields to rename, then it might be a bad idea. So I have renamed as many fields as possible. And if you look at the node now, it has become really big, right? So this is how the DAG looks like. This is a Spark DAG. And the reason it has become complex, because I'm adding 5 tables which are in S3, and I'm renaming multiple fields. Finally, I want to add that sensitive data detection. it is provided by Glue out of the box. It is not available in Spark, but it is there in Glue. So I'm mentioning that find the sensitive data in each row and act on each cell individually. This is the first option. The second option is find columns that contain sensitive data. So it will scan a sample of the dataset to quickly find columns that represent sensitive data. I'll select this one, and the sample portion, I think 30% would be enough. In production, it should be 100% though. Detection threshold would be 10%. And if you want, you can select specific patterns, specific categories, or all available types. These are again provided by Glue. What are the types? You can find it in the Glue documentation. I'm not going into the details here. You can select the global detection sensitivity and what is the action you want to take. You want to detect, you want to redact, or you want to hash it. So redact is, it will replace the detected text with a string that we choose, and it can be anything. Let me mention XXXX or maybe capital XXXXX. Okay, finally, I want to write this output in a target, and target should be S3. So that's what I have added here. I have selected targets, and the target would be S3. I could have mentioned Glue data catalog also, but I do not have any object or additional object stored in Glue data catalog. I'll run the same code when we load the table in Aurora, and then from Aurora to Aurora, we'll do the loading later on using Visual ETL or PySpark. Anyway, so the target is also S3, and this is the output. So output S3 finance data. This is the parent node, and the format can be either Parquet, JSON, CSV, etc. Let me select it as Parquet. Compression is snappy, and the target location. So I do not have any folder here, right? So this is the folder where I want to store the output, but inside of Glue output, I do not have any folder. So I'll copy the URI and I'll mention a folder, which is, let's say, finance joined data set, and the end should be always / because it has to be a folder. And after this operation, do you want Glue to update the data catalog? The first option is it will not update the data catalog. The second option is it will create a table in the data catalog, and on subsequent runs, it will update the schema and add new partitions. The final option is create a table in the data catalog, and on subsequent runs, keep existing schema and add new partitions. Then you have file partitioning, which will partition the file, and then I can mention the target database also. And let's say the table name would be finance analyzed data, just a name. And in the Glue data catalog, a table with this name would be created. There's this check data quality also. This is not needed. And that's it. So this is the DAG. It will write to the output location, which is also S3. And I did not do any coding. It was just drag and drop, not even drag and drop, using the adding node and providing some values. So that's why this is a no code experience to create a Spark job. And Glue has automatically created the script. So this is the script that has been created automatically. Now it is a pretty big script. I'll talk about it later on. But as of now, let's go ahead and run this. And in the job details, it's the same. I have not changed anything. And here you can see how many times you have run the job. I can schedule it also. I did not create any schedule. I'll run it on demand. And that's it. Let me go ahead and run the job here. You can use this option, or you can click here also. Now, if I run the job, it will take some time to run, and the output should be stored in the S3 location. Let's wait for the job to complete. If it errors out, of course, we'll debug it.